Okay, let's go over the test B. So we're supposed to plot point A, which is this is the sideways and this is up and down, x direction and y direction, -5 and up and down 0. So that's where A is supposed to be. And B is supposed to be 3, 4. And C is at 3, 7. And you write points as ordered pairs with parentheses. And D is at -5, -4. And E is at sideways 7, down 2. +7, -2. And the quadrants are 1, 2, 3, and 4. And E is in quadrant 4, sometimes used done in Roman numerals. That's that one. 2 points, 2 points, 2, 2, 2, and 2. Okay, now 4 is easiest to do if you figure out the intercepts first. So to find the x-intercept, we put 0 in for y. So -5 times 0 is 0, and so we're left with 2x equals 10. You divide by 2 and x equals 5. And to find the y-intercept, you make x be 0. So if I put 2 times 0, I get 0. So I'm left with -5y equals 10. So I divide by -5 and I get -2. So now to graph this, I'm going to plot 5, 0, and 0, -2. That's 2 places this line goes, and so that's the idea of the line. So there's 4, here's 5, and 6. Supposed to draw where all the y coordinates are -2. Y is the up and down, so I got to be down 2, and I can be sideways 0 or 1 or 2 or 3 or any amount sideways. So there's y equals -2. 3 points, 3 points, 2 points. Okay, page 2. So we're supposed to solve this for x. I have x's on both sides of the equal sign. I want to collect them on one side, so I'm going to subtract 5x, subtract 5x. I could have subtracted 7x from both sides, but I was looking ahead and I don't want to do 5 minus 7, get a -2. I like plus numbers better, as I suspect most of you do. So 7 minus 5 is 2x minus 2 equals 9. Add 2 to both sides, and I get 2x equals 11. Divide by 2, and I get x equals 11 halves, or 5.5, or 5.5. Any of those answers. This one, we should distribute the 4 first, and so we're going to get 24, and -5 times 4 is -20. X equals 15 plus 10x. A bunch of negative x's here, so I'm going to add 20 x's to both sides because I like to keep the x's positive. So I get 30 x's and a 15 equal to, these are gone, and so it's just 24. And so to move the 15 off of here, I'm going to subtract 15 from both sides. And that gets rid of that, and I get 30 x is equal to 9. So now it's 30 times x, so I divide by 30. And the 30s cancel, and I get x equals 9 over 30, which would have been an acceptable answer. 3-bit goes into both of those. So it could have been 3 over 10, or in decimal, 3 divided by 10 is 0.3. Any of those. Okay, next one. A builder is renting a compressor, and Ace Rentals wants to charge $75 and $5 for each hour it's used, while URent rents the same compressor for $60 and $8 an hour. So the cost from renting from Ace Rentals, C, is equal to $75 plus $5 times the number of hours, which I said let that be X. The cost from URent is going to be $60 plus $8 times the number of hours. So when will these two costs be equal? It's when that equals that. So let's see what that is. 75 plus 5x equals 60 plus 8x. So I've got 5x's, 8x. I'm going to take 5x's off of both sides. And that gives me 75 equals 60 plus 3x. I'm going to subtract 60 from both sides. And I get 15 is 3x. And if I divide by 3, I get x equals 5. This is a story problem, so there's probably units for this. And x was standing for the number of hours, so 5 hours. Now, which company costs less for a small number of hours? Well, for a small number of hours, Ace, if this x is small, the 75 is going to be more important than the 60. Again, that's that power rule. If we're looking for close to 0, x being small, close to 0, it's the other term that makes the difference, and it's the 60. So URent is less because, now it's called the upfront cost, but you can also say because it starts with less, namely $60. Or you can say the upfront costs are less, they're $60. So URent is less because of this. Okay, page 3. Alexa hikes to a lookout averaging 2 miles an hour, returns because it's coming downhill 3 miles an hour. Total time is 3.5 hours. How far is the hike? Expression for the time. So distance is your speed times the time. So if I want an expression for time, I'm going to have to divide both sides by the speed. So expression for the time it takes to get to the lookout d miles away. It's going to be d divided by her speed, which was 2. That's the time going to the lookout. Time coming back, since she was going faster, it's going to be d divided by 3. So what is the distance? Well, the time going to the lookout plus the time coming back is the total amount of time, which was 3.5 hours. Now, to solve one that has fractions, you multiply by the common denominator, which is 6. So I'm going to multiply by 6, 6, and 6. 2 goes into 6, makes 3D. 3 goes into 6, makes 2D. 3.5 times 6 is 21. 3D plus 2D is 5. D equals 21. Divide by 5. And D, the distance, is 21 divided by 5, or 4 1/5, or 4.2. And this is a word problem, so there's some meaning and there's some units. And this distance is, since it's miles per hour, would have to be miles. Okay. The 3 is times the parentheses, so we got to take 3 times the 3. And 3 times a minus 2i, which is minus 6i. And this subtract of all of this, so we got to take the subtract on that, so it's minus 1. And minus a minus 6i is plus 6i's. Combine like terms, so we have 9 minus 1, 8. And minus 6i plus 6i's is no i's. They cancel each other out. Now you can leave the 0i off if you want. You don't have to put it on there. Now we got to multiply. And so we have to do the FOIL, multiply all the pairs. So we got to take 2i times 4i, which is 8i squared. 2i times a negative 3 is negative 6i. Then negative 3 times 4 is negative 12i. And negative 3 times negative 3 is plus 9. I squared, since I is the square root of minus 1, if you square it, you get negative 1. So negative 1 times 8 is negative 8 minus 6i plus minus 12i plus 9. So we got minus 8 plus 9 is 1. Minus 6i's minus 12 more is minus 18i's. And on the, I had to correct this on here so that it was factorable. So minus 6 plus 3x squared equals negative 7x. When you're trying to solve by factoring, you want it equal to 0. So I'm going to have to add 7x to both sides. And then you want to put them in order, starting with the highest power, the most powerful, far from 0. So you're going to go 3x squared plus 7x minus 6. We've got to factor this, so we're going to line 7 up with 0. And we want to get negative 18, so one of these has got to be negative. So I'm going to go negative 1 and 8, negative 2 and 9, and those two happen to multiply to be negative 18. So I have x minus 2 and x plus 9. But I need to have 3x squared. Can't get the 3 here because that's a 2. But I can here by dividing by 3 and multiplying by 3. So I get 3x minus 2 and x plus 3. And that's supposed to equal 0. If I have two things that multiply to be equal to 0, either this is 0 or this is 0. If I solve this by adding 2 and dividing by 3, I get x equals 2/3, or subtracting 3 from both sides, I get x equals -3. And the last page. If I can get this paper to move. Okay. Last page. Using the quadratic formula. Again, when you solve quadratics, you want them equal to 0. So we have 4x squared. I can subtract x from both sides, and I can subtract 2 from both sides and have it equal to 0. Or I could have subtracted from this side 4x squared, and so I'd have minus 4x squared plus x plus 2. All it does is change the sign of the a, b's, and c's, depending on which way you move them. They're going to be the same. So I'm going to just use the one I'd had. Remember, a is the number of x squareds. It's not x squared, it's the number of them, 4. It's the leading coefficient. B is the number of x's. Now, several of you wanted to put x here, but it says there's minus 1x. So B is -1. And C is the constant, which is -2. And some of you forgot to put the quadratic formula on your note card. It's the opposite of b over 2a plus or minus the square root of b squared minus 4 times a times c, and all of that is over 2a. That's what the x solution is to this. So I have to do the opposite of b, which is 1 over 2 times a plus or minus square root in the numerator. B squared minus 1 squared is 1. -4 times 4 times -2. -4 times 4 is -16, times -2 is plus 32 over 2a, which is 8. And that's what x equals. Now you could have written this as 1/8 plus the square root of 33 over 8, or 1/8 minus the square root of 33 over 8. This one, x is only in one place, so you're tasked with undoing to figure out what x is. So the outside, there's a times 2. To get rid of a times, you divide. So we get the 5th root of x squared plus 32 equals 3. Now, some of you from our working class who know that 32 is 2 to the 5th, and so you thought you would pull it out. But when there's a plus connecting them, tying them, you just can't pull out one part or the other part. But we can undo the 5th root by taking it to the 5th power. Now the way to look at that is the 5th root means it's to the 1/5 power. And so to get rid of the 1/5, you take that both sides to the 5th power. 5th power, both sides to the 5th power. This makes 5 times 1, 5 over 5, which is 1. So we get x squared plus 32 equals, see, 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. So I'm going to subtract 32 from both sides. And I get x squared equals 211. And quite a few of you got this far. And to get rid of the square, you took the square root, and so you said it was equal to the square root of 211. But there's two numbers that you can square to get this. The positive square root of 211 and the negative square root of 211. Now you could change the decimals if you want, but you don't need to. This is in between notation. The negative 7 is smaller than negative 8. It's not equal to negative 7, so I use a parenthesis, negative 7, and between it up to negative 4, and in the set. Solid bracket because it's equal. A bracket as opposed to a parenthesis because that side was unequal. So this is all the numbers between negative 7 and 4, including the negative 4. We're not between here, so we can't write it like this. We have to write it in two pieces, like it shows. We have all the numbers that start at negative infinity and work up to 1, since it's a solid dot, including the 1. And since we have two separate pieces, we have to group them together with a union, a U. And then we got to start at 4, not counting the 4, so that's a parenthesis, up through infinity. Okay, now we're supposed to solve this. It's an inequality. You solve just like an equality, except if you divide or multiply by a negative, then you got to flip the inequality. So I'm going to subtract 2 from both sides, and I get negative 5x less than, I'm subtracting, so I don't have to flip it. And 12 minus 2 is 10. I'm going to divide both sides by negative 5. Now I'm dividing by negative 5, so x greater than or equal to negative 2. Now, if the absolute value has to be bigger than 6, then you have to be more than 6 one way or more than 6 the other way. It's two pieces, like this graph. If it was less than, it would be in between. So this 2x minus 4 has to be greater than 6 for this piece, or the 2x minus 4 has to be less than negative 6. Solving this by adding 4, you get 2x is less than negative 2. Divide both sides by a positive 2, so we don't have to flip sign. We get x less than negative 1. Or adding 4, we get 2x is greater than, adding 4, 10. Dividing by 2, both sides, we're dividing, but it's positive, so we don't have to flip it, and we get x is greater than 5. So it's less than minus 1 or greater than 5, so it's split in two pieces. So we write it from negative infinity up to negative 1, not including, union from 5, and the numbers we want are bigger than 5, up to infinity.